Welcome to Unit 6. Here we go with Unit 6. We've gotten through well over half of your algebra studies. So here we begin. We're going to be looking at solving quadratic equations by factoring. Notice here that I said equations because before we've just had expressions. Now we're going to have some equations that actually have an equal sign. We're going to be setting them equal to particular numbers and solving for unknowns. Here's a math career for you. How about a geologist? Now this is a real hands-on science job. If you like science and you like math and maybe even you like computer stuff because you're going to have to work with that and maybe even some traveling, geology would be quite a job for you. You can see your salary there starts off fairly modest but still okay, and then it jumps up, almost quadruples there at the high end, so very nice. And there's your math you need down there. So today we're going to learn to solve quadratic equations by factoring. And here's the key word here, equations. We haven't really seen equations yet in dealing with this factoring stuff, so we're going to see that today. Here's a real quick review vocabulary for you. A zero of a function. These are the x-intercepts, which will set the equation to 0. Now you remember this from Unit 5. The zero of a function, we call those roots, we call those solutions, we call those x-intercepts, of course, and we're going to really focus in on the zero of a function here, and you'll see why pretty quickly. Alright, so let's take a look just as a quick overlap. Determine how many zeros each function has and why. So take a look at these. Here's function A, B, and C. You'll take a look here. Look at function A. Tell me how many zeros you have there. Function B, do the same, and function C. Hopefully you said you have 1 0 here for function A. There's no zeros for function B, and yet there's 2 for function C. And you can tell by how many times that function, each one individually, touches or crosses the x-axis. So we see again that we can have 1 or 2 possible x-intercepts, and occasionally we'll have 0, no real roots there for your functions. So some vocabulary here. The zero product property. Now this is really, really important, not just for Algebra 1, but extending on into our studies beyond into geometry and Algebra 2. If the product of two quantities equals 0. Remember what product means. Product means the answer to a multiplication problem. If the product of two quantities equals 0, at least one of the quantities must be equal to 0. So that's the written part. The math part says if A times B equals 0, then logically what follows? Then either A or B has to be the number 0. The only way to get a multiplication answer of 0 is that at least one of those factors there has to be the number 0. Okay? Alright, so again, if the product of two quantities equals 0, see if you can finish that statement on your own. Of course, then at least one of the quantities must be equal to 0. Alright, very good. How about this? Zero product property. If the product of two quantities equals 0, at least one of them must be 0. So let's look at a typical example. If x times y equals 0, then either x or y, and I know I've said this now 3 times, but that's how important it is. You've got to realize no matter what you're multiplying together, if your answer is 0, then whatever it is times whatever it is, one of those guys has to be the number 0. So let's look at a specific example. What if you're given this? X minus 3 times x plus 7 equals 0. Now remember that x minus 3 is just one number. It's just whatever x is, subtract 3. So if x is 10, that number is 7. If x is 100, that's 97. If x is 4, that's a 1. The fact is we just don't know what x is. So we don't care. It's a single number written in 2 terms, x minus 3 times x plus 7. So we know that if x minus 3 times the other number, x plus 7, has to be 0, then one of them must be 0. So the question to you is, what value for x in the first one would make that a true statement? If we wanted to set x minus 3 to 0, let's just do some straightforward algebra, super easy, add 3 to both sides. Therefore, x must be 3 on the left, correct? What about on the right? What value for x would make that sum 0? Something plus 7 is 0. Well, that something has to be its additive inverse, or negative 7. So if we add negative 7 to both sides, we get 0. Sorry about flash forward there. So what are our two responses then? Our two responses, what are the zeros or the results of this? X can equal negative 7 or negative 3. Why is that? Well, if you take negative 7 and put it right here, you get this negative 7 minus 3 times 0. If you put 3 here, you get 0 times 3 plus 7, which is still 0. So either way you go, you end up with a product of 0. All right, a little bit faster now. Your turn. Let's take a look and see what you've got. How about you write this one down? X plus 2 times x minus 3 equals 0. Try this one on your own if you can. If you can, pause the video and try it. If not, just be patient here. I'm going to help you out. What I'm going to do here is I'm going to take x plus 2 and x minus 3 and split them. So I'm going to set x plus 2 over here and set it equal to 0 and come up with a number for x that if I add it to 2 I get 0, which we know, of course, add negative 2 to both sides. So what does x have to be? X has to be negative 2. Now let's do the same to the other side. What value for x there would make that 0? Something subtract 3 is 0. What's the something? Well, add 3 to both sides just to be sure. And the answer, of course, is x equals 3. So your final result, in order for these two factors to multiply to 0, x has to be negative 2 and or 3, depending on the number of answers we want here. Okay? So negative 2 and 3 are the result. Let's try this one. How about x times x minus 6? Well, x times x minus 6, let's see. I don't see anything there. This is actually even easier because now we're just going to take the left-hand x, this guy over here, and we're just going to say, you know what? I'm going to let x be 0. I'm done. I just assume x is 0, and wouldn't that wipe everything out here? If x was 0, this would be 0 times negative 6, of course, is 0. This one, let's do what we did before. Subtract 6 from both sides. I'm sorry, we are subtracting 6, so let's add 6 to both sides. Add 6 to both sides here, and we end up with an answer of 6. So what are our two solutions? The two possible solutions, x equals 0, x equals 6. There's your solution. They're written, we use these brackets, what's called a solution set. Set notation is another way to say it, but you want to write your answer preferably from least to greatest. So that's why I had negative 7, negative 3, or negative 7, positive 3, now 0, 6. So there's your answer, your solution set there, 0, 6. Let's look at one more. Now this one gets a little messier here. This takes a little more getting used to, but 3x plus 2 times the quantity 2x minus 3 equals 0. Do the same thing. Break it into two different problems. Take 3x plus 2, set equal to 0. Now, what's our first step here? Our first step is to subtract 2, get it out of the way. Okay? This is a little bit of flashback to 7th grade here, solving equations. So we subtract 2 from both sides, and then once we subtract 2, how do we get x by itself? Divide both sides by the number 3. The opposite of multiplying by 3 is to divide by 3, and so your first result there sits right here, negative 2/3. Now let's work with the next one. The next one is negative 2x minus 3 equals 0. Let's do this. Let's add 3. If you remember, what you did before was you got rid of what's farthest away from your variable there. So we're going to add 3 to both sides. We get 2x equals 3, divide both sides by 2, and we get another fraction, and it's perfectly fine to have two fractions. Our answer here is going to be the set negative 2/3 and 3/2, or 3/2. It's perfectly fine to have fractions as answers. This will come up less frequently than you might imagine. We'll mainly just be dealing with some straight up integer roots. But nonetheless, this is how we'll handle this. So have these in your notes. That's what we asked you to do right up here with this. Have this information in your notes. Bring it to school to the next time I see you, and we'll have some more practice at this. Okay? If you want to have a little different approach, maybe you can see Dr. Berger and his work over at thinkcentral.com. There's your keyword, and you can watch video example 1. All right then. We'll talk to you soon.